All right, section 10.1, and oops, okay, I'm good. Yep. Section 10.1, and we are dealing with circles. So we skipped chapter 9. I just don't know if I'm just trying to think of what you're going to use later on and what you see on like achievement tests and things like that. And the thing that in chapter 9, I think it's fine to skip because there's no way we're going to hit every single chapter in this book. So I'm trying to hit some highlight chapters, okay, some chapters that I think are probably more important than others. I'm not saying chapter 9 is not completely important, but between you and me, yeah, they could get rid of that chapter for all I care. All right, so we're going to go to chapter 10, which is circles. This is kind of a fun chapter. I kind of like this because it's kind of familiar. A lot of the beginning stuff anyway is familiar. We're going to definitely hit some stuff that's going to be things that you haven't seen before. But we're also going to relate back to things that we've taught before, like perpendicular, things like that, like different angles. We're going to be dealing with angles. We're going to be dealing with things that are perpendicular. And you think, well, circles, how in the world would you deal with an angle? How would you deal with lines that are perpendicular? How would you deal with stuff like that? Well, you'll see. All right, so let's do that. So let's put a circle on here. And let's just, basically today, it's just kind of like a lot of definition stuff. We'll learn a couple formulas, and then we'll be good. So here's a nice little circle. This point right here, this point right here is equidistant from all points on that circle. When I talk about the circle, I'm talking about just the line itself. Everybody see that? The line going around it. A lot of people think of it as like a disc and say, oh, this is on the circle. Well, that's not on the circle. This right here is on the circle. What do you think? Where do you think that point would be? It would be inside, right, or in the circle, exactly right. So this would be in the circle. This would be on the circle. What do you think if we had a point out here? Where would that be? Be outside the circle. Does that make sense? Okay, so that's pretty important because we're going to be talking about that really throughout this whole chapter. All right, so this is a point inside the circle, but guess what? It's equidistant. This point right here is equidistant from any point on the circle. So if I drew that to there and I drew this segment to there, okay, those two segments right there are equidistant. So I could put a little tick mark right there. Does that make sense? So a circle basically is this. It's the set of all points the same distance or equidistant from this point right here. What do you think we call this? This is in the circle, but more specifically, if this point right here is the same exact distance from every single point on that circle, what do you think we call that? It's the center of the circle. Okay, it's the center of the circle. We don't say it's the middle. I understand what you're saying if you say middle, but we call it the center of the circle. Right? So that's very important. So that point right there is the center of the circle, and it's only the center if it's equidistant from all the points on that circle. You see it? I could sit here all day and keep drawing points from this center point all the way to any point on the circle, and all those line segments are going to be the same distance. They're going to be exactly the same. Does that make any sense? That's basically the definition of a circle. Let's talk about those line segments right there. That line segment from the center, and let's get rid of this little tick mark here. Let's talk about from the center to a point on the circle. See, this is on the circle. So if I go from the center to the circle, we give that a name. And remember, I said you probably learned this stuff back in 6th grade. You probably know that name right there without even looking in the books. Does anybody know? It's the radius, right? That's the radius of the circle. Raise your hand if you've seen radius before, if you've been taught radius. Yeah, absolutely. Almost everybody in here, okay? And if you didn't raise your hand, I bet you anything that you were taught this at some point, okay? So this is the radius of the circle. And the radius of the circle is the length from the center to any point on the circle. So if I wanted to, I could, let's do this. Let's draw this in another color. I could go from here anywhere. Look, I could go anywhere on this circle right here. And if I go from there to there, guess what that blue one's called? That blue one's a radius as well, isn't it? All right, so let's say this length from, we'll call this A, and we'll call this B, and we'll call this C, because these are points, right? Point on the circle, point in the circle. So we'll say AB. Tell me something about AB and AC, the length of AB and AC. They're exactly the same, that's right. So the length of AB, do you remember how we draw the length of AB. We don't put the little line segment over top of it. We just put a AB, nothing over top. That means the length of line segment AB is equal to the length of what? Line segment AC. So that's true. Why? Because they're both the radius. Now, that's singular. Radius is 1. What if I had 2 of them? Would it be radiuses? No? It'd be radii, yeah. So the plural is radii. R-A-D-I-I. Okay, it's not radiuses. It's just radii. All right? No, I know. I was being silly when I said that. But it's still not radiuses. It's radii. It's right there. The plural of radius is radii. All right? So I have 2 radii. I have 1 what? Radius. All right. I told you it would be pretty simple when we do this. All right. Let's do this. Let's actually extend this one radius. And let's do this. Let's take it from here, and I'm going to extend it all the way to the other side of the circle. Now look at this thing right here. Let's do this in a different color. You probably already know this, but that's right. So that thing right there, we'll call that C. So from C to B is, look where it goes through though. This is very important. It goes through the center, doesn't it? All right, so it's a line segment that hits 2 points on the circle. So C is on the circle, B is on the circle. This thing right here, this line segment, hits 2 points on the circle, and it goes through the radius. If I have something that goes through the radius and hits 2 points on the circle, Nate, what is it again? It's the diameter. All right, so that's the diameter of the circle. What do you think might be true as far as the lengths of the radius compared to the diameter? Say it. Yeah, the diameter, just write it like this. I'll put diameter is equal to what? 2 times the radius. Exactly right. So it's double the radius. So if I have 2 radii, right, back to back, do you see it? One starting at the center going to one point and one going exactly 180 degrees in the other direction, then that would be diameter. All right, so the whole thing is a diameter. Half of it is the radius. Everybody see that? It's not too hard. You know what they're going to do with this, don't you? They're going to give you numbers. They're going to say, okay, the diameter is 10. What's the radius? It's 5. Easy. It is easy. Okay, that's the kind of stuff that they'll be asking you. Of course, you know it's going to get a little more difficult than that, but that's one of the small things that they're going to ask you to do. We good with that so far? All right. Let's copy this. Let's talk about some other things on this circle. We've actually mentioned a couple things, but I haven't really talked about that diameter. It hit 2 points on the circle, didn't it? Well, watch this. This from here to here. Let's change the color of that. All right. That right there hits 2 points on the circle. Is that the diameter? No. A diameter has got to hit 2 points on the circle, but a diameter has to do what? It's got to go through what? It's got to go through the center, not the middle, the center. We say center. We don't say middle of the circle. We say center of the circle. All right. So this does hit 2 points on the circle, but it doesn't go through the center. So we have a name for that. I heard somebody say it already, and it's a chord. That's right. We call that a chord. Now, is the radius? Let me draw a radius again. Let's just draw it like from here to here. Is the radius a chord? No. Why not? Okay, well, not just because it touches the center, because remember what I said about a chord.
Oh, because the radius is the same
distance. Well, now what did I say about the chord? It's got to hit 2 points on the circle. That's right, okay? Both endpoints, I should say this, both endpoints of that line segment have to be on the circle. Look at this radius. Are both endpoints on the circle? No, only one is, right? This is not on the circle, this is in the circle. So this doesn't go all the way across. A chord has to go all the way across. Everybody see it? So one endpoint is on one part of the circle, the other endpoint is on the other part of the circle. Make sense? All right. Again, today is basically just kind of vocab, just making sure we start, at the same spot, the same place. And there we go. So we got chord, we got radius, got diameter. All right, let's flip the page. Yes, sir.
So diameter would be a quarter.
Exactly right. I'm glad you said that because I should have thought about saying that. Let's extend this radius all the way out to where it actually hits on the circle. So now, this right here is a diameter, right? So this is a diameter. So it must also be a what? It must be a chord. So every diameter is a chord. Is every chord a diameter? No, it's not. Okay, because absolutely this pink chord right here is not a diameter because it doesn't go through the center. But any chord that goes through the center, if you want to say it that way, right? Any chord that goes through the center of the circle has got to be a what? A diameter. Got it? Travis?
Where the chord and diameter cross, are we going to define those angles?
There are not exactly where a chord and a diameter cross, but there are going to be some lessons where you definitely are going to find some angles and things like that. That's why at the very beginning I said we're going to talk about perpendicular, we're going to talk about angles, we're going to talk about a lot of stuff that we have talked about in the past. Okay, so it's all going to come back to you. I almost said it was going to come back to haunt you, but hopefully it's not haunting you. Hopefully you learn the stuff, right? And then it comes back to help you out. Okay, not to haunt you, but to help you. All right, so there we go. Chord and a diameter. Yeah, they give some examples, but I think we're okay with that, right? If the diameter, remember I said if the diameter is 10, what's the radius? It's 5. What if the radius was 3? What would the diameter of that circle be? It'd be 6, okay? Now, how many diameters are there on this particular circle right here? You see one, but how many actually exist? That's right, an infinite number, right? I could draw diameters all day long, all week long, all year long, all my life long if I wanted to, couldn't I? All right, and I could never draw every single diameter. All right, and you're like, well, yeah, you will, because then they'll start touching each other and stuff like that. But really, when you draw these line segments don't have any width or any dimension at all, so you could just keep drawing for literally forever and ever and ever if you wanted to. But that would be a waste of time, wouldn't it? I got a lot better things to do than draw a bunch of diameters on a circle. All right, so let's do this. They don't talk about this too much, but I'll mention it. And then there. Talk about what? Pi?
Yeah.
Yes, we do. Watch what I'm going to do here, though. Again, we don't really deal with this all that much, but I thought I'd just throw it out there. I want these centers to line up. That's pretty close. That's close enough, okay? What we have here is if I have one circle inside another circle, and they both circles have the same center, right? This little circle has this as a center, and the big circle has this as a center. We call them concentric circles. All right? Call them concentric circles. And that's basically all they do here. Yeah, they just give you the definition. There's really not much we're going to do with concentric circles. If I keep putting circles in here, it starts looking like a bullseye a little bit, right? So when you see a bullseye, that's basically a bunch of concentric circles. They have the same radius, right? Because this would be the bullseye, right? Okay, that's where you want to try to, hit your arrow or gun or whatever you're going to do. And that would be the center of all these circles. So if that's the center of all these circles, then that would be concentric circles. Let's do this. Let's do another. Again, this is just definition. This actually will come into play from time to time. Let's make this just a little smaller so I can fit a couple of them in here. And we copied and pasted, okay? So you didn't see it, but trust me. I copied and I pasted. So guess what's true about the radius of this circle? That radius and that radius right there. If I copied and pasted these circles, what must be true about both radii? That they're equal to each other, right? So if I said that these were, we call these congruent circles, all right? If I copied and pasted, okay, congruent circles. Congruent circles means both circles have the same radius. All right, everybody see that? So if you have congruent circles, if you have two circles and they both have the same radius, that must mean they're exactly the same. I could take this and, tell you what, I'll just take this and just move it over, and if I put it right on top of the other one, it fits exactly. Well, it's supposed to fit exactly if I could line it up, right? So that circle fits exactly on top of the other one. So that would mean that we have congruent circles. Let's see if I can, there we go. All right, back to it. All right, so this would be pretty easy. If I said that these circles are congruent to each other and I said the radius of this was 5, right? If these were congruent circles, then what's the radius of this circle over here? It's pretty easy, right? What would the diameter of this circle over here be? It'd be 10, all right? Boy, this seems way too easy, doesn't it? It's got to get harder, doesn't it? Well, not yet. Let's see what else we can say. We could have circles that intersect each other. Let's do that. And let's just make this one a little bit smaller. They don't have to be exactly the same. Okay, so here we go. Let's just move this, center it up a little bit more. We have two circles right here, and they intersect each other. They intersect each other right here and right here. All right, so they're intersecting circles. Well, they have an example actually for this. So let's do this example real quick. Let's use this purple right here. Watch what I'm going to do. I'm going to connect from here to here. Okay, and let's put some numbers in here. Actually, some letters. RC. This is R. This is C. That point right there. Okay, that's C. D and S. Doesn't look exactly like the one in the book, but it's pretty close to what we have in here. Now, it says the diameter. Oh, I almost forgot to tell you. I should have told you at the very beginning. There's a symbol. You know how you had symbol for angle, you had symbol for triangle, you had symbol for line segment, you had symbols for parallelogram. Remember all that? Well, guess what? You also have a symbol for what? A circle. And here's the symbol for a circle. It's a circle. How about that? But they put a little dot in there. Why do they put a little dot right there? Because it represents what? The center of the circle. So what we do, whatever the point is for the center, like this bigger circle right here, the center is at point R, isn't it? So what do you think we're going to call it? We're going to call it circle what? R. That's it. You don't have to use like 3 points around it like you did with a triangle, or 4 of them for a parallelogram or a square rectangle. You just use 1 point, and it's the center of the circle. That's the important point. So if I wanted to name this circle, I would call it circle R. So what would I call this little circle? Circle S. So you put a little circle symbol, you put an S, and that's circle S. That tells you something. What does it tell you? It tells you that the center of the circle is where? Is at S, point S. Everybody see that? I should have told you that right at the beginning, but that's okay. Now you know. So here's what they say. They say the diameter of circle S, actually I should have switched these around just to be consistent. I don't know. Is that alright? We'll just go, sorry about this. Because they have the little one on the left and the big one on the right. Let's just do this. Let's just move it over like this, just so it looks a little bit more like the one in the book. Because I don't want you freaking out when you see the example in the book and say, that's not what it looks like. Alright, so there you go. There's that. And let's rename this again. This is R, this is C, this is D right there, and this is S. Alright, now we're back to where we want to be. It says the diameter of S, of circle S, the diameter is equal to 30. And then it says the diameter of circle R is 20. So the diameter is 20. And it says line segment DS is 9. And it says find CD. Find the length of CD. Alright, well, let's start putting some stuff in here and see what we get. The diameter of circle R, this little one right here, is 20. So what can we find if I know the diameter is 20? I know the radius, right? So I know what? RD. So what would RD be equal to? 10. Alright, so we'll just put that right in there. Does that make sense? Alright. And DS is 9, right? That little bit right there. Actually, let's do this. From there to there is 9. And what else? The diameter of circle S, the big circle, is 30. So what's the do this in different color so it, okay, just right up here. And then what's the radius of circle S then? 15. So that means from here to here is 15. Did I confuse you enough on that? Alright. What are we trying to find? CD, that little bit. This little tiny bit right here. That's what we're trying to find. So what do you think? Well, look, from here to here, from C to S is 15, right? From R to D is what? 10. I don't know, does that help you out? What are we trying to do? Oh, let's do the 15 and the 9. Right, yeah, that's better. Look, from C to S is 15. So from here to here is 15. From D to S is 9. Everybody see that? So C to S is the whole thing, 15. D to S is 9. So what do we do to find that little tiny bit right there? 15 minus 9. Okay, 15 minus 9 is 6. And so that's what CD is. All right? I wrote this a little smaller than I should have. I should have made it a little bit bigger so you could see it better, but you get the idea, I think. What do you think? That's not too hard, is it? All right. So nothing's been really hard so far, has it? Now, somebody asked me about this earlier. Here's a circle. And what we're going to do, again, you probably learned this in middle school, I would think. Even before you started taking your algebras, you probably learned this stuff right here, is my guess. Is we want to find the distance around the circle, or the perimeter, right? You had a problem on the test, didn't you, where it was the perimeter? What is the perimeter? It's not just one side, it's what? It's all the sides added up. But you don't really have sides to a circle, do you? So you don't really add up all the sides, but what is the, what's the distance around it? It's the circumference, exactly right. Now, I probably won't draw this very accurately, but that's okay. I'll make it a little bit thicker. So the distance, try to stay on the circle, the distance all the way around, okay? That length all the way around. So think of it, I think of it as a string, right? You had a nice perfect circle, you cut the string, and then you stretch the string out like this. If I measured that length of that string, that's the distance around the thing. It's the perimeter of the circle, but we give it a special name, and I've heard a couple people say it already. What's the special name for the perimeter of a circle? It's the circumference, right? Circumference. All right? So the circumference is the distance around the circle. It's basically the perimeter of a circle, okay? So even if I said find the perimeter, you should be able to find it. It's the same thing as the circumference. Well, we got a little formula for this. Without looking in the book, maybe some of you already did, but without looking in the book, does anybody remember what the circumference of a circle is? It's 2 pi r. That's right. It's 2 pi r. Or you could write it another way. Watch. What's twice the radius? If I take the radius and double it, what do I really... It's the diameter, right? So you could write circumference is pi times what? The diameter. It's the same exact thing. Would you agree? So if you have a problem and they give you the radius, I would use this formula, right? You just double the radius, and then you multiply it by pi. Well, let's talk about pi for a second. What is pi? Okay, we'll stick with 3.14. You're right, it does keep on going. It goes on forever and ever, but we'll just stop it at 3.14. Okay, it's approximately, I should put a little squiggly there. It's approximately 3.14. When you're a kid in elementary or middle school, they gave you a fraction. Do you remember what that fraction was? 22 over 7, that's right. Now this is approximately pi. This is not exactly pi. We don't use this number right here, okay, when we do stuff in here. We'll just use 3.14, and in fact your calculator, let me give me a second here to get the calculator going. And the calculator, actually, I remember how I always had to change it to degrees. I actually saved it so that when I open it up, it's in degrees now. So let's go to this, let's go to this. Right, so I saved it, hopefully, let's see if I did. Yep, see it's in degrees right now. Wasn't that smart of me? Well, we're not gonna deal with radians now. We're gonna just deal with degrees in this book. But when you get into Algebra 2 and pre-calc especially, you will deal with stuff that are in radians. We're not even going to touch that right now as far as what radians are. You can worry about that in Algebra 2. Okay. So what was I going to show you? Oh, I was going to show you pi. Right? See the pi button right there? It's a second function on this calculator. So you hit second function, this up arrow, and then there's pi. I guess you hit enter. There it is. Okay, that's as many places as this calculator takes it out, but it's 3.14. What if you hit 22 sevenths? 22 over 7. It's not the same thing, is it? It's 3.14, but then it changes right after that. So is 22 over 7 exactly the same thing as pi? No, it's a close approximation, isn't it? So it's a fraction that's very close to what pi is, but it's not exactly pi. So we don't use 22/7. We'll just use either the pi button on the calculator or just 3.14. Okay? I'm not sure. I'll have to look at how they write the answers. I can't remember if they use the pi button on the calculator or they use just 3.14. We'll have to, you could always try it, right? Try an odd problem, stick in 3.14, see if you get exactly the same answer that they get in the back, and then try one with the pi button on the calculator, 3.14159, blah, 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 and then see which one you get for the answers. And that'll tell you what they use here. All right, so that's pretty easy. So if they told you the radius, real quick, watch, we'll just use this one right here. So if they told you the radius was, I don't know, 3, and they said, what's the distance around this circle? What is the circumference of the circle? So what do? You go, circumference is 2 pi r. What is r? It's 3. So basically, it's just 6 times pi, right? So I would go, on this calculator, you can just hit 6 pi. 6 pi, and puts it in there. And so let's round it to 1 decimal place. So 18 point what? 8. So 18.8. Now, if you wanted to, you could just write it 6 pi. If you want to just write it 6 pi and not even put it into a calculator, I would be okay with that, to tell you the truth. My guess is, though, that this is what the answer you'll see in the book. I used to teach out of a book for many years, and they preferred that you just write it 6 pi and not even put it as a decimal, because they tried to get you to stay away from the calculator as much as possible. So they said, hey, look, once you get to that, that's fine. Look, I could teach any little kid to put 6 times pi in a calculator, right? So this is the work. This is what I really want you to see. But this is probably what you'll see in the books, so that's perfectly fine. All right? Make sense? All right, what if they told you the circumference? What if they told you the circumference? I'm just going to make some number up. Let's say 30. We'll use the problem from before. Let's say you had a problem and the circumference was 30 and you had to find the radius. All right, and they said, what is the radius? Put radius equals question mark. So what in the world would you do? Yeah, well, what I would do is this. I would put the formula here, 2 pi r. I wouldn't use pi times diameter, would you? I mean, you could, and then you'd have to take half of it, right? So I would just use 2 pi r. So look, if I want to get r by itself, let's do a little algebra before we throw some numbers in. This is what I like to do. Just hang on a second. What would the algebra be? How would I get rid of 2 pi? Divide by 2 pi. So watch. So if I divide this by 2 pi, divide this by 2 pi, that's the radius. The radius is circumference over 2 pi. So what do? You just throw the number in now, right? 30 over 2 pi. You could put that in your calculator, or watch, you could just do what? 15 over pi. So you stick in, watch this, 15 divided by pi. Let's use the pi button. Equals 4. We're around at 1 decimal place, that would be 4.8. So the radius is 4.8. Let me give you some problems to do, so you can practice this yourself. Here we go. This is section 10.1. It's pages 687, 688.
John Hamrick, Scrappy,
Number...
Joe Robinson, Tyson Bishop, Jamie Brown, Judah Dorsey.
I'm sure Jonathan's
Nate
getting a
Haney,
special award
Billy
because he's been so
McKenzie.
good. I'm sure that's what it's been.